This is the ozone layer. It sits miles above Earth and it serves as a shield from the harmful radiations emitted from the sun. Ozone depletion, like other environmental problems, is very troubling and rightly so considered as a major environmental issue. To better understand ozone depletion, we first need to understand what the ozone layer is. Ozone is a natural gas composed of 3 oxygen atoms. Its chemical formula is O3. Environmental scientists have classified ozone into 2 sections, good ozone and bad ozone. Good ozone or stratospheric ozone sits in the upper stratosphere, which is a layer of space 6 to 30 miles above Earth. When UV light strikes O2 molecules, they are split into 2 individual O atoms. When one of the O atoms combines with O2 molecules, ozone is created. It's called good ozone for obvious reasons, because it protects humans, life, and animals on Earth. We also have the bad ozone, also known as tropospheric ozone. This gas is found in the troposphere, the layer that forms the immediate atmosphere. Bad ozone does not naturally exist as it is caused by human actions. Each time there's a reaction of chemicals such as those found in cars, power plants, and factory emissions in the presence of sunlight, bad ozone is created. Bad ozone contaminates the air and contributes to what we typically experience as smog or haze. The ozone layer is depleting, which simply put means that the amount of ozone in the stratosphere is decreasing. Chlorofluorocarbons, or CFCs, heavily used by industries in the past 50 years, are the major cause of the deterioration of the ozone layer. These substances are heavier than air, but over time, in about 2 to 5 years, they are carried high into the stratosphere by wind action. When CFCs are high enough, UV radiation breaks up the CFCs and by doing so, producing chlorine atoms. Chlorine atoms react with ozone, and then that chlorine reacts with another oxygen atom to regenerate itself back to chlorine. So one chlorine molecule can destroy many ozone molecules. In fact, according to the US Environmental Protection Agency, one chlorine molecule can destroy more than 100,000 ozone molecules. When volcanoes erupt, they produce massive clouds of ashes into the troposphere, which include high concentration of bromine and chlorine. In these volcanic ashes are some chemicals including bromine and chlorine that belong to a group of highly reactive elements called halogens that need electrons to become stable. They get these electrons from the ozone gas. Scientists have noted that halogens from volcanoes contain twice and thrice as much as halogen that human activities even produce. Although the potential of depleting the ozone layer is higher with volcanic smoke, it is known that volcanoes contribute to about only 18 to 20% of the chlorine entering the atmosphere, whereas human activities contribute to about 80 to 82%. Antarctica was an early victim of ozone destruction. This region's low temperature speed up the conversion of CFCs to chlorine. Satellite images were released showing a disturbing thinning of the ozone layer. The phenomena is what we usually call the ozone hole, although it's not really a hole, but a thinning of the ozone layer. This series of images show the size and shape of the ozone hole each year from 1979 through 2012. The measurements were made by NASA's Total Ozone Mapping Spectrometer instruments. Purple and dark blue areas are part of the ozone hole, and those areas have drastically grown over the decades. Without the ozone layer, life on Earth would be almost nothing. Depletion of the ozone layer has consequences on humans, animals, and plants. This typically results from the higher UV levels reaching us on Earth. Research confirms that high levels of UV rays can cause skin cancer and cataracts in humans. This is why it is important to wear UV protection sunglasses and sunscreen when you stay in the sun to minimize the UV effect on your skin and eyes. The question now is that what can be done and what can we do about ozone depletion? Ozone is a natural gas and it replenishes itself over time. The only way we can help is to remove the excess chlorine and bromine from the stratosphere, which means we have to stop making CFCs and several other chemicals. Ozone is critical for life on Earth, and that is why learning about ozone depletion is the most important step towards a safe environment in the future.